Okay, so to start the exercise session, you will reproduce what I did this morning to prepare the Pixi project from the base state that we give you to something which is a Python package organized project. So that's the first thing. I think some of you already did it during the morning. So if you're done, very good. Second thing, you configure your IDE to work with the Pixi environment. So if you have issues with that, don't hesitate to ask us. And then basically we have just one big exercise, which is, form a group with your neighbors and start to refactor the code, practice making branches to implement new features, etc., merge them, make pull requests with your peers, review, etc., etc. So that's just a thing. There are further exercises which we don't plan to do during the session. It would take far too long. They're just here to explain how we ended up to the solution that we will give you for tomorrow. What's the reason it's implemented this way, basically, if you are interested to have a read. So it's just the steps that the questions we ask ourselves to decide how we will make the final implementation, but this is not a recipe you have to follow in any special way. The goal is just to practice, it's not a Python class, so the goal is not to teach how to program in Python, it's just to practice using Git and refactoring and working with Pixi. So I think for now, I'll let maybe 10 minutes, something like this, for you to set up your IDE, your environment, etc. As a first thing. Before if you are done, you can start already thinking how you want to refactor the Pixi, so it would be exercise 3. After the 10 minutes, if everybody is set up, we will try to make a session together on what are the things we want to implement in Pixi. Do we want to have some classes for some abstractions? Do we want to have some functions, etc.? So we can together discuss this a bit. To do some collaborative design. We'll just open a whiteboard and we discuss. But it's not mandatory to do what we decide. You can start before if you already have an idea, okay? So give you 10 minutes for everybody to be set up, and then we do the collaborative design, yeah? Okay, so let's start. You can follow the two first exercises. So is everybody done setting up the environment with Pixi and setting up its IDE? Is anybody not ready? Let me ask like this. Does anyone need more time? No? Okay, so we can maybe continue. The goal is to try to work on the Pixi and make some changes and then collaborate with others. So we can have a look at the code and maybe try to decide what modification we want to make first, collaboratively, so we don't, go in all directions. So, I don't know what you think. What is the changes we should introduce when you come to a script like this? The first thing we should try to do probably is to understand what it's doing, right? So let's try to go through it and understand. First, we load some data. This is a mistake from me, I think. Then there is a plot already. So we create a figure with matplotlib and we are going to make the plot. That's the violin plot, is the thing you saw on the figure, right? Okay. So this is just plotting. Okay, then we compute maximum, minimum values from our two data structures, so X and Y. This one I renamed, okay. So this one I will also remain while I'm at it, call it cups, just to make it consistent. Okay, so we have the ranges of our distribution, let's say. Then what is happening here? We define a list of dictionaries that contains quite a few things. So we have a name, something which is a list of numbers, thing which is called bounds, which is also a list of numbers, but only 2 values. And then a lambda function. So this is a function, a Python function that has no name, but that you can still call on some input and it will perform the computation, right? So this would take the first argument named xx, then a0, a1, a2, and the result of the function would be this. So calling this is the return value, basically. Okay, so we have a few of those. Different functions, different names, right? So it seems to be like we have different models that we try to fit on the data, maybe. And okay, so then we have this for loop, which is calling a function which seems to be doing a fit. We can have a look actually at the documentation of this function in your IDE if you just put your mouse over it or you click on it. Yeah, so this is fitting a function basically. Okay, so basically this for loop is going to fit each one of our models using this scipy function. We see that the other parameters that were used, they are passed to this fit function. So the P0, we can look what the P0 argument is. It's defined here. P0 is the initial guess for the parameters. So it's like the fit starting point for the parameter values, right? And then bounds is the, where is bound? Bound is the lower and upper bounds on each parameter value. So when you make a fit, you can say, you can constrain your parameter to go in a certain range. Those are the bounds that are passed, basically. Okay, so we make the fit. Then this line is pretty difficult to understand. But basically, M is one of the models. It's one of this directory. We're going to access the F field. So we're going to access this for this one. So we're going to access this function. And so we are going to call the function from the model in the dictionary on the input, which is cups, and passing the other arguments, which is the return value of the fit. So if you try to follow the logic, what this is doing, even though it's not very explicit, is that it's using the fitted parameters to evaluate the function that you just fitted on the input. So it's making the prediction of the fitted model on the input. Okay. Then there's a few computation, difficult to follow, right? The names are ugly. We see it compute a value which is called R2. So if you have a bit of experience with fits, maybe this rings a bell. You think, ah, okay, maybe have an idea what this is. This is the quality of the fit. It's an indicator of the quality of the fit. In order to be sure, we'd have to understand what this is actually doing, and we check, is it really computing the thing that we expect it is, right? Since it's not documented, that's our only goal, but chances are that's what it's doing. And finally, it's appending the results. So a new dictionary is created with the name, which was the name of the model, the function, which is the function of the model, and the parameters, which are the result of the fit. And this indicator of the goodness of the fit, basically. So we are here trying to create a list of our results. Then there is call to a sort on this list. So this is the sort function of Python. So maybe you have used it, maybe not. But basically, if we try to understand what's going on, is we have a list of dictionaries. We are going to apply a key function to apply the sorting, which tells you what field of inside your dictionary you need to compare to order your list. And the field we are accessing is this one, so the dr2 field. So basically, we are trying to sort the thing per decreasing order, because of this reverse, decreasing order of goodness of fit. So the first argument of the list would be the model with the best fit, then the second fit, the second best one, etc. in order. So as you can see, it's pretty difficult to infer all that just reading the code. Finally, there's a new array created, it's smooth. It goes, so using the link space, we just create an array with a certain number of data points, which goes from the minimum value that we had in the input to the maximum value of the input. So this is basically creating a fake input, smoothly distributed input array. And then we call our fitted model on this input. So this is the same call than this one, so making the prediction, but on this new input smooth array. And we call plot with a certain label, which is the name of the model. So this is plotting the models that were fitted on the same actually figure that was created all the way above here. So it's adding the model curves onto the plot that it was done at the beginning. So if you remember what the plot looked like, I can run it again. Yeah, what would be the best way? Maybe like this. So the first plot is creating this violin plot for each column, and then the second plot is adding the lines, which is the prediction of the model over the input range, right? So that's what our script is doing. It's pretty difficult to understand, right? I think I knew the answer, so it was not so hard for me to explain, but probably difficult to parse to begin with. So we can try to think maybe what would be good ideas for refactoring for this script. Does anyone has a proposition? When we begin, we can think of the concepts that we have. So I can try to open a whiteboard, and we like do a sort of a brainstorming session to understand. So at first we load some data. So we have some data. Okay. That's maybe one concept to keep in mind. Then we have the plot, so we can add the plot. And just write plot for now. Okay, then we had a bit of computation. I don't really know how to call this. Then we had something which was called model, so it seems to be maybe an abstraction which is suited to our problem. We create these sort of structures which are representative of a model that we try to fit. So there are two concepts maybe. There is the model itself, which is a function that we want to evaluate. So this I can detail a bit. It's the function that we want to have, and also the parameters value, basically. The model in itself doesn't know which value of the parameter to use, so we can maybe group them together. Okay, that's one concept. The model should be fitable, so maybe that's another concept we can add, right? Yeah, this is big enough. Okay, and finally we have some more plotting. There is the sort, but maybe it's not so important at the moment. So that's what we have basically. Okay. So yeah. Yes, exactly. So we can add that also. Scoring, maybe sorting would be like a subset of this. Okay. So now we have an abstract view of the thing. We can try to think how the things relate to one another, what is the connections between the different concepts. Okay. So when I make a plot, I basically need a model and some data to evaluate on. So we've seen this X-move array, so we can try to link these together. So I'll just make some connections. These two. Okay. When we do the scoring, basically we have a model and we have the goodness of it. So this seems to be only using the model itself, right? Once, sorry? And the data, yeah. So maybe I should not have moved it somewhere around. Okay. So let me maybe move it somewhere here. Okay. And so finally we have this fit concept of being fitable. So this is related also to the model, which are the things that we try to fit, right? But then we also use the data, right, to make the fit. So we have something which looks a bit like this. It's not so clean, bit of a mess, but we can see some connections. Okay, so now basically we have like a abstract view of what we want to achieve with the code. The question is how we translate this into Python objects. For this, that's like a programming in Python question. And in this school, we don't teach you how to program in Python, right? Because we don't have the time. That would take a whole week on its own just to get started. So I'm just going to assume that you have a few ideas, right? What is how to implement things in Python. The goal is not to evaluate you on the Python knowledge that you have or to make a really clean implementation now. It's just to think together how we want to do this. So, yeah, does anyone has an idea how we could represent this in Python object? We can actually have a look at what objects we had before, right? So we had list and dictionaries that grouped objects together, okay? We had this is a function that we call, but it's not our own, it's from an external dependency. So we have basically data structures that hold a few things, models, and then we have some functions that we evaluate. Yes, this is also some sort of data structure. So it's read with pandas. So at first it's a pandas data frame. Then this converts to NumPy. So it's basically an array of values from NumPy. So those kind of already have classes attributed to them in the code, right? Which seem to be adequate. An array to store an array of values seems like a good idea, right? How should we represent the rest? There's one thing which seems to be a bit centric to this stuff is the model. So we have the model concept. A model can be evaluated on some input. The model has a function that is evaluated, basically, so that's how it was implemented so far. And it has the parameters to pass to the function to evaluate. What would be a good implementation of this abstract concept in Python?
Using a class.
Class, yeah. Good choice, I would say. So what do we want inside our class?
The attributes, the keys of each dictionary.
Yeah. I don't know how to write it nicely here. try to write that down, right? So like a class model, for instance, and then we have attributes for the two things. So we have a function, we have parameters, okay, why not?
And we can have separate YAML file for all the.
Sorry, I didn't.
We can have separate YAML file to keep all the comments.
Yeah, okay. So one thing we didn't talk about, yes, is the values that we have in the code. So we could put them into a configuration file in YAML, for instance, yeah. So it's not here in the graph, but we could add it to have like a configuration. Yeah, good point. Okay, so our model, he needs to interact with the plotting, with the scoring, and with the function that does the fit. So how do we implement something like this? Let's say with the fit first, as a first question. We have our class, we have a model which is a class, it has a function, it has a parameters values, we need to pass it. So this fitable concept is the abstract view that we have, but in practice, it's not something that we implement ourselves, right? It's something that is coming from an external library, which is this curve fit function, which is coming from SciPy optimized package. So it's not, we cannot decide how to use this function. The API is given for us. So we, in fact, don't have a lot of room here to choose. And if we look at the call, so here we pass the model function. We pass the data. So the data you fit on and the predictions, basically, that you try to match with your fit. Then we pass the parameters and we pass the bounds. So something we were missing maybe here is the bounds, right? But actually maybe the bounds are not related to the model itself, maybe they're more related to the fit, I don't know. So I could add something like this maybe to say that, okay, when we make a fit, we need to constrain the parameter somehow. So if we make our class like this, then we could call the curve fit function, and we have our instance of the class, and we pass the field to the right things. Okay, should work. What other interface we have? We have the scoring. So if we look at how it was done so far, it's basically calling the model functions on some input with the parameters also given. So that's the call to the function, which is our parameter. So this seems to work also as well, but we kind of make a lot of calls to this function member that we have. Maybe it would be a good idea to enrich this class with, you would say, method that we could call predict, and it takes like the data to evaluate on as input, and it would, it would basically return the value of the data, right? This is a pseudocode. Okay, we can go on like this for a while, I think, trying to figure out what are the different things. So, now we try. Thomas, on a jusqu'à quand pour la. C'est jusqu'à. Okay. Okay, we have 10 minutes to try to implement something and to collaborate together. So let's try to form groups. I think we can try to make groups of 3. So maybe you try to meet with the people on the same row as you to make groups of 2 or 3. And the idea is that one of you is going to try to implement this model class. So it's not, we're not judging your Python thing. So just try to make something, and then we will just try to merge this to practice Git and working with GitHub. It's not to make a full solution. So one of you can try to implement this model class. The other one can try to think how to implement the the scoring. So the scoring should receive this model class and then compute the score value. That is another task. And maybe if you make group of 3, you need a third task. So you can think of the plotting, how you can group all the plotting that is made. At the moment, it's distributed over the entire file, right? We have the plot which is at the beginning, which is reduced at the end. So how can you group that together in maybe one function that takes a model, takes some data, evaluates the model, and then makes the plot, something like this. So that is my proposal for you for the next 10 minutes. Let's go, try it. Okay, guys, so I think we're going to stop here because it's late enough. So what we are going to do tonight, or I don't know if you've done it tomorrow already, is that we are going to push the solution of the refactoring made by the teacher of the school to the Pixi repository. That's so tomorrow you can all start from the same state to discuss the test and the following features for the rest of the week. So the goal was just for you to practice a bit the refactoring, but we will now push the final solution. We can have another look at this solution just to show you how it looked like, what we had in mind. It's basically the outcome of the refactoring if you follow all the exercises that we had, which was not planned that you do, one more time. It took several days, to implement this solution by several teachers, so it was not expected you do everything. But that's basically the result. So the organization is a package like we had before. Wait, it's not this one I want to show you. It's this. We have the source layout, so source Pixi. The entry point has been changed, basically named to something which is CLI for command line interface. So you have here something which is using argparse, like Max was showing before. This is to remove the usage of the hard-coded value for the output file, for the input file, for instance, of the script that we had at the beginning, to take over arguments like what do we have for the plot? For instance, we have some arguments for the figures, what is the range you want in your plot, these kind of things, which were hard-coded in the previous script. Now they are arguments of the global thing. So that would be the entry point. Then you have a class implemented in fit model for the model, like we were discussing. So this is Python specific, but it's a data class, so it's just a helper to define less stuff in your class. And then it has basically a name, the functions that we had before, which are implemented in a separate file, the parameters and the bounds, all in the model class. Assembled. Also the quality of the fit, R-square, which is basically initialized to -infinity. So if you did not do any fit, you have no value. But then when you do the fit, it's modified and you get the value of the fit. Functions we just factorized and used here in a dedicated file. The solution is using something which is maybe a bit complicated for Python, so it's not a recommendation to follow this, but I was just trying it out to see if it works. Turns out it doesn't work so much because the syntax is not entirely finished on the Python side. The way it works is I didn't want to make a class to represent the functions. I wanted to use something which is called a protocol that defines an interface without forcing you to have the members defined in your class. It's something which is a bit similar to the traits in Rust. If some of you work with Rust, maybe you have the idea. So the idea is that I don't make a class that has a method predict and then I inherit from this. So I need to implement the predict method. Is to say, okay, all the class that obey this protocol must have a predict function. That's how this protocol thing works. So you define the protocol and you say, okay, my function, it needs to have a function. It's not called predict, it's just called call. So it's just the function thing. And then it should take one first argument, which is the array, and then any kind of arguments with names, with not names, whatever you want. That are the parameters of the functions, basically. So the A0, A1, etc. So this is just Python details. I just explain it to you. So if you're interested, you can have a look. It's not really important for the rest of the school. And then basically all the functions are here, and they implement this interface. So they all define the call function, which is the implementation of the function that you had in the starting script. The functions, they also implement this param_guest method, which is something which was a bit hidden in the initial script, which was basically this part here. Here you had some computation going on to find the initial parameters, so it was not explicit, but that was the idea, and so now it's implemented as a method of the function itself. Because some functions, you cannot evaluate them on some input. They are not valid for negative numbers, for example, something like this. So now it's part of the function abstraction. Same thing for like default values for the parameter bounds. If you cannot be on negative value, maybe the minimum value you can allow is 0, these kind of things. Okay. So one thing which is added in every file, so I forgot to say it first, but it's the documentation. So that's something you should always do when you implement, basically, is to write the documentation to your functions. So in Python, it consists in putting docstring pretty much on every object you define. That's a very good practice that you should follow. What else do we have? For the computation of the quality of the fit, we have another module to store this concept. So it's just a few functions to compute the R2 value that we had, right? So it's assembled in one file. And finally, all the plotting things are put inside the visualization module. So it's all stuck here. There is a few classes to store the parameters that you want for your function, etc., etc. And then it's just a few functions that call the same plot that we had previously. That's basically the refactoring of the ideas. Then we've added a few things to improve the software, thinking, this is an application which is becoming big. We want to run it on a computing cluster, so it's going to take a lot of resources. What is the modification we should add to make this possible? The first one we did is to implement some logging. So we have here a module that implements some helper function for the logging. It's, when you execute on a computing cluster, you don't have a screen attached to every screen, every node in the computing center. So if you want to know what happened during the execution, you need to log information to know what happens. So that would be done by the logging. In the same spirit, sometimes when you go to a computing cluster, you have the issue that the machines inside, they don't have any graphical interface available. So your libraries that make the plot, they cannot be installed because there is nothing on the system to make the graphical interface. So for this, we split basically the analysis from the computation, from the plotting, from the visualization. So the idea is you have two commands in your pcoffee, in the command line interface. You have two commands defined at the top here. One is doing the analysis, so you just load the data, feed the model, then you save the models to file. Here it's JSON or TOML, but that's not relevant, right? Then the visualization, you just load the model again, you make the prediction on some input, and then you make the plot, basically. So that's also a good practice that you can try to follow if you think your analysis is going someday to run on a big computing cluster. That's a nice distinction to make. Okay, I think that's all. We finish like here. Okay. Do we push the solution right now? Okay. You can do it. Okay. So yeah, just to go back to show you in the pcoffee repository, the one you forked to start working, Thomas is going to push the solution that I just showed you, so that tomorrow you will start from this. It has all the definitions we have done with Pixi and the refactoring. It's done. You take it for granted. And tomorrow you discuss the test and the continuous integration. And for the rest of the week, you just add things to this already implemented solution. Okay, I think that's all.
Maybe you can quickly show how to make a pull request to
Okay.
I can show it.
Yeah, I'm just, what change do I include?
Because people have made in group some change to the branch and they want to make a request to their.
Okay. So maybe we can make a drawing for this to make it easy to understand. Tu veux? Okay. So just to explain, you had the initial pcoffee repository. Let me add. Yeah. So this is the first one that you forked. So now you have a fork. Each one of you has a fork. So I'm going to call it fork 1, let's say. If you made a group of, say, 2 people, because I'm lazy, you have 2 forks. And then you guys then cloned the fork. So you have a local, on your machine, you have a local copy of the repository, which is like this. So you're basically probably in this kind of situation. What you want to do to be able to collaborate is to add as a remote. Okay, let me add a third one to make it more explicit, maybe. Okay. What you want to do to be able to make a pull request is to add one of the forks of your group to like you select someone and you say this one is going to be the one we collaborate all together on. So for instance, let's say we decide to take for 2. What you want to do, this one already has the remote set to this fork. So this guy doesn't have anything to do. This guy and this guy, they need to add as a remote, they need to add as a remote a link to this repository. So it's the remote thing that Max showed during the class. You add a remote to this repository. You can call it, you already have upstream maybe, so not upstream, something else. Group. Yeah, for instance, you use the username. And then you will be able to make a pull request to this repository. But for now, you probably don't have the right. So the guy who owns this repository should add the 2 people he's working with, their user, GitHub user. He should add them to the repository to give them the permission to
I think that's actually not necessary to open the pull request.
No.
It's not needed? Okay, good.
Still push to your fork.
Yes.
And then when you open the merge request, there's a button, compare across forks. And then you could choose the fork 2 as the target of the main of the merge request, of the pull request.
Okay, even better then.
You
You want to, okay,
fork 2
okay.
as a remote because you would need to update, right? After you integrated some changes, you will need to update the results, but you would still, in this setup, still push your own
Okay.
branch and open the merge request against the other fork.
So.
Si je te donne le micro peut-être.
Ah.
Comment ça marche?
I made just a simple change to my own fork of the copy repository, which I made in a branch called data. Celui-là aussi. To mics. And now I want to make a pull request to one of your fork. So I can simply go to my GitHub repo. You see here, it's my fork from the main one. Can increase a bit. And if I go to pull requests, I can go to new pull request. And here, the base repository where I want to make the pull request, if I just click, I can see all of your forks. So if I want to fork to one of you, to make a pull request to one of you, I just pick randomly, sorry. And I want to make the pull request from data branch. Let's see. So who is Pirax? Hello. You just received the pull request. So you can...
Sorry.
It's fine. So I made a very simple change here just to make a new data file to load the data. And now you should find a pull request on your GitHub, and you can make comments that should... This is exactly the window you should see, and maybe you can make a comment like, no, I don't want this pull request, or something like that, or you can review and yeah, we can discuss about the change I made. Try to make a comment. We should see it open. If I maybe reload. Okay. Did you make a comment to a specific file or to the main? Okay. Okay, yeah. Well, this is how you should make the pull request very simply. Because you don't necessarily need to know the people who will make a pull request to your repo. So. Okay, I think we can end. It's been a long day already. Maybe quick comment from Romain to end the day.
Yes, I have 1 hour of presentation to finish. No, I will only try to wrap up. I'm really happy to see that we have more than 5 pages of suggestion of content, and what I would like from you only to do until tomorrow during the day is to add your initials everywhere you are agree. That's only the thing that I ask to you, but it's important just because after we will choose what are the main criteria, what are not. At this step, we have several things that could be decided now, just because we have 5, 6, or until 8 initials in front of the ID, is that we need a kind of rationale. So I will try something that you will have to review tomorrow during the day, not this evening. And we have also some elements like glossaries that are necessary. So I will open a section where you will note all terms that could create a kind of confusion on your side. And after we will decide how to define them to be clear. Because if you don't use the same terms and another for developing software, you will have problem to understand your colleagues. And that's something that we cannot permit in the checklist. After, you will see that we will continue on the same way, so it's not very difficult to note your IDs. I will not push you again for that, but please continue at each session, and it's valuable not only for people that are participating, but also for speakers. Just because we have advice, for instance, I didn't have the time to note your last advice here. So please have a look and add also your ideas. It is really important to have something really consistent. And there are some topics that are forgotten, and I will try to propose you each time, each evening, one slide with a topic that you don't know really or related to a topic like I had a question from two of you about variable naming, for instance, on naming conventions. It's not really well known, but if you want to do something reusable by the most of the communities, you need to know them at least if you want to apply them. Finished.
Thank you.